Hey everybody, Trey here. Welcome back to another video. It's been a little while since our last video on the channel. I had some things to take care of. But we're back now, ready to get going with some more content. Now that storm season has wound down quite a bit, I thought we'd kind of go through some more educational content, similar to the SKUT and hodograph series that we just finished up, if you're interested in that. And learning more about SKUTs and hodographs or improving your skills on how to read those diagrams. I'll put a link to that playlist in the description below. And also some case studies. The case studies seem to go over pretty well with you guys, going deep into the meteorology of these kind of infamous or famous sort of tornado cases. So I thought we'd start up today with one of the most notable events of the last several years as far as storm chasing goes. If you are a storm chaser or a weather weenie for that matter, and you either know about this event or you were there for this event. And that's the Dodge City, Kansas TornadoFest, as I like to call it, of May 24th, 2016, in which we had a cyclic supercell thunderstorm produce approximately 13 tornadoes just from one single storm. It was a pretty incredible day. Had multiple tornadoes in progress at one time, at times, and it was just a pretty incredible event to be there for. And I was actually there. This is my photo in the background. Had two tornadoes in progress at once. At times we had three in progress, and there were some strong tornadoes with this. The highest rated one was an EF3 tornado. So wanted to start off back with the content here, going through this case and go through deep into the meteorology of this case and kind of determine why this storm was able to go so nuts, as it's kind of one of the more sort of banner events of really the last decade or so, and perhaps even farther back in storm chasing lore. So let's go ahead and get started here. This is what you woke up to on the morning of the 24th. This was the initial Storm Prediction Center Day 1 convective outlook, and there were two areas of heightened severe weather potential across the plains. We had one here across northeast Colorado into southwest Nebraska, and then the main one here was kind of along the Kansas-Oklahoma border, southwest Kansas into northwest Oklahoma. Originally, there was a small 10% area straddling that Kansas-Oklahoma border there, but by 1630Z, both of these areas had a small 10% area associated with them. So Storm Prediction Center was basically telling you if you want to see tornadoes, go to either of these two places. They were very, very small areas spatially as far as the 10% areas go. But why exactly was that? So it all starts with the night before. So this was late on the 23rd. This would been about 0Z, 7 p.m. Central Daylight Time on the 23rd. Couple different areas of convection here. We had one area down here into northwest Texas produced a pretty significant tornado here near Turkey, Texas. After dark, I was on that storm, was able to witness that. It was a pretty big wedge tornado near Turkey, Texas, that resulted from a storm merger. And then there was also some tornadic activity up near Woodward, near Sunset here across northwest Oklahoma. So those were the two main areas on the 23rd. And then overnight, we had a big complex of convection fire up across northern Kansas. My guess would be it was kind of a north of the warm front type situation where we had lots of storms firing north of the warm front, elevated convection that was able to sustain itself throughout the overnight and early morning hours. And you can see on the radar that it kind of pushed out this pretty broad outflow boundary here. You can kind of see here the eastern extent of that outflow boundary here, that kind of fine line right in here. Was able to push out an outflow boundary, and it kind of extended all the way back here into northern Kansas. And we can see it really nicely on visible satellite. It would eventually kind of drape across southern Kansas and kind of stall there throughout the afternoon. You can see here, this is at about 15Z, so 10 a.m. Central Daylight Time here. You can kind of see that fine line there across southern Kansas. Actually fired some convection there early in the morning there as well. Very visible on satellite. This is our visible satellite imagery here. So this would start on the evening of the 23rd. We'll go into the morning hours on the 24th, and you can just see this is about as well-defined of an outflow boundary as it gets here. Fine line of clouds here extending from eastern Kansas all the way into western Kansas. And this, when you see this on the morning of a chase day, you know that something, and you have the background parameters there for a big severe weather event, you are pretty confident there's going to be some enhancement of the low-level shear and likely an enhancement of the tornado potential along this outflow boundary. And you can see that it kind of stalled out here across southern Kansas, kind of just baked away as the sun warmed the surface here throughout the afternoon. Very much visible on the surface map as well. So this is at 10Z. So 5 a.m. Central Daylight Time, you can see the wind shift here. Complex of convection ongoing here across northern Kansas. And right in here is where we had our outflow boundary. You can see northerly winds here to the north of this boundary. Southerly winds right here. Some easterly winds right along that boundary. So you can see here about 5 a.m. it was located somewhere in here, I would say. And that jives with our radar imagery. You can see that it does shift south throughout the day. So this is at 13Z. Some more easterly flow, kind of winds have gone around to more easterly here to the north of the boundary. Still southerly winds to the south here, so definitely kind of drapes somewhere out in here, roughly speaking, as we go into the morning hours on the 24th. So you could actually argue that there's kind of two different boundaries here. So you can see low 50s here across northern Kansas, mid 60s here across southwest Kansas. So there's definitely kind of one boundary in here. You could also argue that there's another one in here. You can see the wind shift. Southerly winds or southwesterly winds across central into northern Oklahoma here, with easterly winds across southern Kansas. And you can also see a temperature difference here. Mid 60s here across southern Kansas, increasing to low 70s here across where those southerly winds are into Oklahoma. So you could argue that there's two different boundaries here across the region. One draped here from the convection, ongoing convection, and then another one here across southern Kansas into northern Oklahoma. And both of these, I think, would be able to provide a focus for severe weather potential in the afternoon hours. Also, notice that we have 50s dew points here into Colorado as we go through the morning hours, increasing to sort of broad low to mid 50s throughout the afternoon, with nice upslope flow across northeast Colorado. 20 knots of easterly flow here at the surface. Always an eye-opener when you have decent moisture up here with a nice big trough into northeast Colorado. That usually always signals some sort of severe weather day and likely an increase in tornado potential up there as well. So again, there were two different areas here. You can see at the surface, very nice plot of moisture here lurking into Oklahoma, 70s dew points up into northern Oklahoma, central and northern Oklahoma, getting just ready to get pumped into southwest Kansas as the day progressed, given the decent southerly to easterly or southeasterly flow here across the region. So let's go on to our background environment here, our synoptic scale environment here. So this is going to be at 500 millibars, so about 18,000 feet aloft. And you can see here, very nice broad troughing across the western half of the U.S. And if you recall, this was a period that was basically a several-day period of severe weather across the plains. So you just had this big old trough here sitting across the west coast with these little sort of perturbations kind of flowing through that enhanced sort of belt of flow across the western half of the United States. So this is, when you see something like this, just kind of broad southwesterly flow, nice trough sitting off the west coast, broad southwesterly flow, just kind of parked across the southern and central plains with these little sort of kinks in the height contours here flowing through that region. That is kind of eye-opening as well, because you have subtle southwesterly flow, much favorable. The forcing is not super strong, favorable for isolated supercell development here with the right sort of background environment as well. But these little perturbations, this was the one that kind of helped, was the impetus for that Northwest Texas event on the 23rd. And as we go through the day here, you can see you just have this kind of trough just parked across the west coast here, parked across California, the Great Basin, with just broad southwesterly flow across the western half of the high plains here. So this is a pretty typical environment for your bigger sort of tornado days. Big trough out here across the west coast, enhanced belt of flow here rounding the base of that trough with these little sort of kinks in the height contours helping to influence localized sort of convective development. And we had one little shortwave here you can see on 500 millibars here rotating through here. Little enhancement of flow here right out ahead of the main belt of flow here across southwest Kansas. Nice little perturbation there as well. Beautiful divergence or defluence aloft here. You can see the wind barbs here more out of the southwest here, veering to south-southwest here across southwest Kansas. So a nice area of localized divergence here ahead of a nice little shortwave here. This is about as classic as it gets for big sort of isolated supercell tornado days on the plains. When you have this combined with your nice moisture at the surface and just a textbook sort of outflow boundary situation here across the plains. It's probably going to be a pretty solid tornado day here. Nice perturbation here at 500 millibars flowing through the region here, approaching southwest Kansas, outflow boundary to help focus the low level, an enhancement of the low level shear. Everything was shaping up to be a pretty solid day here across this portion of southwest Kansas into northwest Oklahoma here. So let's go ahead and go down to 700 millibars. So we'll go to 700 millibars here and take a look at the sort of lower level flow. We can better see these perturbations. You can see a bunch of little perturbations here. Morning of the 24th, little sort of kinks in the isobars here across the region. Just a bunch of little subtleties in that flow that helped to impact that localized convective development in the afternoon. And by 15Z, 10 a.m., this was 16, 17Z, so early afternoon, you can just see nice little perturbation here extending up into Colorado to help out that northeast Colorado play, extending all the way down in the Texas Panhandle, moving toward the northwest Oklahoma, southwest Kansas vicinity. So this was a very nice little shortwave here. It actually became a little bit more amplified as we went through the afternoon, likely because we had nice surface flow development, lee cyclogenesis here, with that nice easterly flow, or southwesterly flow, traversing the Rockies. Whenever you have this kind of flow here, belt of southwesterly flow, more zonal flow traversing this high mountain range here, what it'll do is it'll create surface flow development here on the lee side of the Rockies. We have this kind of perturbation here. The flow kind of focused right here across Colorado. So we got probably enhanced surface flow development here somewhere in southeast Colorado into southwest Kansas. So let's go to the surface here and kind of show you here. This is with the isobars contoured in. So overnight on the 23rd, you can see that we had a nice surface low situated there in southeast Colorado there, 1,004 millibar low. Right in there helped to initiate the convection and help sustain that convection on the 23rd up in northwest Oklahoma and northwest Texas. We kind of lose that throughout the day, kind of broadens out here through the morning hours of the 24th. Then you can see by 1920Z, we kind of get a consolidation of that surface flow somewhere here in central to southeast Colorado, helping pump that southeasterly surface flow and that nice moisture in the low levels here up into northwest Oklahoma, southwest Kansas. And then this is 21Z, so about 4 p.m., and you can see by 22Z, very nice, well-defined surface flow here across southeast Colorado once again. So nice lee cyclogenesis processes at play. It doesn't get more classic than this. When you have this nice trough, nice surface flow here, lee cyclogenesis across southeast Colorado, ample moisture here at the surface with an outflow boundary sort of becoming sort of this effective warm front sort of feature here across southeast Kansas. This was about as obvious as it gets as far as a target goes. If you're playing southwest Kansas, this is this southernmost 10% tornado area, you'd want to be somewhere right in there, somewhere north of Liberal, south of Dodge City, was pretty much being bullseyed here. Everything that you looked at was bullseyeing that area. One more thing here, let's take a look at 850 millibars, take a look at our low-level jet here. So we'll go back, of course, nice nocturnal low-level jet here across the southern plains, helping to kind of keep that convection going. And we do see some semblance of a warm front here. Wind shift there, warm front, kind of a pseudo warm front outflow boundary kind of combination there. And you have that convection kind of blowing up there to the north across northern Kansas, helping push out that outflow boundary that would stall across southern Kansas. So that low-level jet would kind of course, taper off through the morning hours, but then it would, by early to mid-afternoon, you could see kind of that renewed surface low development, low-level cyclone there, and this moisture just feeding up into that cyclone there, little dry line bulge there across southwest Kansas, and just another sign that was pointing to southwest Kansas. So, this was not one of those cases where it was kind of a surprise event, not one of those cases that was telling you, it might be a marginal chase day, maybe some low-end tornado potential, but mostly large hail and damaging winds from maybe a supercell or two across, a larger area. This was pretty much bullseyeing right across southwest Kansas there. Everything was telling you to get to southwest Kansas. You can see here, we'll go kind of do the dew point here, just to show you how that moisture was kind of wrapping into that surface low, that renewed surface low there in southeast Colorado. Just a beautiful moisture tongue there into southwest Kansas, dry line bulge there, telling you to be right there, somewhere north of Liberal, south of Dodge City was going to be the initial play. So storms first went up across the northernmost outflow boundary here. If you recall, we did have kind of two different boundaries here. We went through the afternoon though, and they kind of washed out. That's what you want with outflow boundaries. You don't want a really sharp sort of gradient here with kind of, for example, northerly winds meeting southerly winds here along a boundary. That tends to increase the amount of forcing, increase the number of storms that develops. You want that boundary to kind of wash out a little bit. And you can see here that's exactly what happened. You have nice southerly flow and a very subtle change to southeasterly flow here right along that outflow boundary here near Dodge City. You can see the dry line here, 66 dew point Dodge City, 54 here at basically Syracuse, with 57 here at Liberal, 68 at Gage. So the dry line was somewhere in here, and nice little bulge there. 84 over 66, 80 over 69 here at Dodge City. So this atmosphere was pretty much ripe for tornadic supercell development in the afternoon. Very subtle, again, southerly flow here in northern Oklahoma, southeasterly flow into southeast Kansas, and kind of just slightly more southeasterly flow, a little bit more of an easterly component up here. So very subtle sort of secondary boundary up here across kind of central to northwest Kansas, to the north of that kind of other boundary here, draped across southern Kansas here. So the first storms of the day actually went up here on this northern boundary. And we were sitting down here, we're kind of along the Kansas-Oklahoma border, watching these storms go with tornado reports coming in. And we were getting a little bit concerned that might be the storm of the day. This was the radar from that time period. You can see that this is at 2032Z here. So this would be about 3:30 p.m. First storms start to go up here near Scott City, just west of Scott City, Kansas, and produced a couple of tornadoes here. You can see it takes on that nice supercell shape. You can see on radar here, very pronounced dry line here showing up on radar. You know you have a nice, beautiful dry line there when it shows up on radar here. You can kind of even see that bulge there in the dry line there into southwest Kansas. But this was the first storm of the day, kind of on that initial sort of northern outflow boundary here. Was able to produce a few tornadoes with that storm before anything was even firing down to the south. This was from Scott Sims, a storm chaser here that was on this Scott City storm, and it produced a couple beautiful tornadoes here before anything even fired down there to the south across southwest Kansas. So we were looking at this thinking, oh no, what's going on here? Have we made a mistake? But eventually we would get the storms down to the south to fire. When you have a beautiful dry line like this and everything pointing, converging here across southwest Kansas, this is the Dodge City radar right in here. You know you want to be somewhere in here as to get those storms as they start to fire here in southwest Kansas. You see that storm moves off, and we finally get storm development here just on that dry line bulge on that southernmost outflow boundary here by about just before 5 p.m. Central Daylight Time here, 2154Z, first blips appearing on radar here to the southwest of Dodge City, north of Liberal. And that is where things really started to begin. So we got storm development here. They quickly matured into supercells as we went into the early evening hours. This was what it looked like here. These are some of my photos here. This was what it first looked like just after 5 p.m. And, you know, when you see something like this, you kind of just have a feeling. When all the signs are pointing to southwest Kansas and you see a storm go up, start to look like this, you kind of get those storm chaser tingles. Just a beautiful, flat, broad base here. Explosive thunderstorm development here. And the progression started to form a nice small wall cloud here under that flat base. The base would expand here over the next few minutes. Again, this was just after 5 p.m., about 5:30 p.m. Continued to have the wall cloud that would continue to grow here. Very nice, chunky wall cloud here on this storm as it moved to the north. And you can see this is a little bit of a blurry image here. But you can see wall cloud here starting to develop an inflow tail as well, broad base. You could just tell that this was going to be the storm of the day. Did we think there were going to be 13 tornadoes from it? No. But it did appear that it was going to be a pretty significant sort of storm right along that boundary once again. So first the first sort of mesoscale discussion here goes up in the Colorado target. As a matter of fact, it went up in Colorado. That some supercells formed there near the Denver area, tracked to the northeast, and actually produced some nice tornadoes up there as well. This was from Jason Clerk in here. Nice wall cloud there. Tornado here near Woodrow, Colorado. Then a second tornado formed near Akron, Colorado from that storm as well. Nice tornado there near Akron. So that was a nice, if you played the Colorado target, you were not disappointed as well. So let's take a look here. Let's go back and actually look at some soundings here for our southern Kansas target. First MD for that target. For the southern target would be associated with the southern outflow boundary in Oklahoma, actually. Storms actually started to fire into northern Oklahoma first before southwest Kansas or even central Kansas, that Scott City storm. This was at 18Z, so early afternoon, we got storms to fire on that southern outflow boundary. Not quite as favorable, a little bit farther removed from that little perturbation that was moving through. This was pretty much forced solely by the outflow boundary alone. And this produced some large hail, damaging winds, and a brief tornado here as it moved into northern Oklahoma. You can see that Scott City storm start to fire there. Just a beautiful cumulus field here. Some cumulus streets here in the early afternoon. You can see, if we zoom in here a little bit, you can see these kind of lines of clouds here, these kind of clouds, cumulus, in this kind of banded formation. A little bit of stable air remaining here by about 3 p.m. as the Scott City storm fired. In the immediate vicinity of the dry line, you don't see as much of that banding here, so the near dry line environment was becoming quite unstable as well. So that Scott City storm fired, MD mesoscale discussion went up for this in pretty much entire region. You can see the SPC here kind of outline this northernmost outflow boundary by the purple here. And that kind of that second one here draped into northwest Oklahoma as well. There from that kind of renewed surface low development in southeast Colorado. Was expected to be a pretty active evening. Storms were starting to fire here. That Scott City storm starting to fire just right along that outflow boundary. Would move to the north of the boundary, but still a very favorable environment just to the north of that boundary. 79/61 here by early afternoon. This was at 2:30 p.m. Calling for a pretty rampant increase in convection pretty much right after this MD was issued here. So the stage was set for a pretty active afternoon. So again, that first Scott City storm fired. We were all sitting down here in southwest Kansas getting a little bit nervous. And then things eventually started to fire by just before 5 p.m. Central Daylight Time into southwest Kansas. So let's take a look at some soundings here, progression of the soundings here. So this was our southwest Kansas. This is Dodge City at 12Z. So Dodge City at 12Z. Very unstable environment here already, 2,500 joules per kilogram of mixed layer CAPE here. So already quite unstable environment here in the morning hours. Very potent capping inversion here associated with a very nice elevated mixed layer emanating from the desert southwest. So that layer of warm, dry air aloft was going to provide a lid on things across southwest Kansas for much of the morning and afternoon hours, which was a good thing as far as a storm chasing event goes. Would keep a lid on the atmosphere, not allow any kind of crap vection, as we like to call it, to fire throughout the early morning hours into the early afternoon. Down here into Oklahoma, this is going to be Lamont. You can see much of the same. Basically, your classic loaded gun sounding. The moist layer, not super deep here. We have that very sort of stout elevated mixed layer there. Still quite unstable here. Kind of weak-ish flow here as we go aloft, kind of a little bit farther removed from the actual trough and that perturbation that was making its way towards southwest Kansas. We go toward 18 to 19Z Dodge City. So by this point, we were starting to see a very favorable environment for supercells here. Moist layer had deepened somewhat, 77/68, so that nice moist advection to the east of that surface low was allowing moisture to stream in very nicely to the region. Still had that capping inversion remaining. We were still going to need that lift from that approaching perturbation, as well as the outflow boundary to help initiate storms in this environment that was still pretty capped here. Some drier air aloft, so maybe a little bit of a drier entrainment concern to enhance the downdraft potential perhaps, but still This was your basic loaded gun sounding. Surface-based CAPE approaching 5,000, mixed layer CAPE between 2 and 2,500 joules per kilogram there, with a much more favorable look for tornadic supercells here. Your 0 to 1 kilometer shear, very high, 0 to 1 kilometer SRH of 154, effective inflow layer SRH of over 200 meters squared per second squared there. Not going to be a super long hodograph. We didn't have, that kind of 70, 80 knot flow here in the mid to upper levels here. So your hodographs were not super long on this day. Effective bulk shear of 42 knots. That's kind of that sweet spot there. Anything lower, you start to worry about maybe a little bit less of a supercell potential. You get into the upper 20s, low 30s here. Mid to upper 30s into the low 40s is kind of that sweet spot. You don't have too much shear where you have so much, where you have kind of this, in those situations where it's a very strongly forced situation, but you don't have so little shear that you're worried about actual supercells firing in more of a sort of clustered multi-cell mode. Kind of that sweet spot is that 35 to 45 knot range. And we had just that as far as bulk shear goes. As far as venting goes, as we've done before, we like to kind of follow the hodograph as far as to see kind of the construction of the supercell itself. So you have a nice sort of mesocyclone region here. Precipitation venting going to be maybe a little bit of an issue here. We have very kind of chaotic flow here in the mid to upper levels there. So perhaps a little bit more of an HP mode, sort of weak mid-level shear would perhaps, you would tend to think maybe shorter-lived supercells, with all hazards, of course, but maybe the chance for clustering would be a little bit higher after the initial sort of tornadic phase of any supercells that would fire here. Let's go now to our RAP sounding. So this is going to be the RAP proximity sounding right about the time that the storm started to fire here. So we first got initiation just before 22Z or 5 p.m. Central Daylight Time here. Let me blow this up a little bit for you. All right, so this is the RAP proximity sounding here, 22Z at Dodge City, KDDC here. So you can see that we've fully destabilized here. The moist layer is very, very deep now. So we've, again, that surface low, really pumping that moisture in to the east and southeast of it. Very moist air mass in the low levels, helping to kind of overcome, along with the perturbation aloft, helps to overcome that very stout cap that we had in place earlier. Very unstable environment, over 4,000 joules per kilogram of mixed layer CAPE, very steep lapse rates aloft as well, and very strong low-level instability, 0 to 3 kilometer CAPE of 162. That's very, very high. We've talked about cold core events before. You like to see something you often see something, those numbers of 3 CAPE, pretty astounding numbers there in the upper 100s to 200s. And what that means is that any surface vorticity is going to be stretched into the vertical very efficiently, aiding in the tornadogenesis process. And when you have that outflow boundary there, which enhances the low-level shear along it, has lots of spin along that outflow boundary, when you have low-level instability that high, you're going to have very effective stretching of that vorticity to aid in the tornadogenesis process. In an already pretty impressive environment for tornadic supercells, that outflow boundary was only going to help guide things along and help aid in tornadogenesis there in any supercell that formed and would maintain itself near that boundary. So very, very good-looking hodograph for supercells, particularly tornadic supercells, 196, almost 200 meters squared per second squared of effective inflow layer SRH. The venting here, a little bit better on this RAP sounding. The mid-level precipitation would be vented a little bit away from the tornado. Perhaps the upper-level winds helping to kind of vent the precipitation back in front of the mesocyclone, but wasn't too much of a concern as far as nixing tornado potential. We go from 22 to 23Z here at Dodge City, and pretty much the same environment. Wind shear has actually increased a little bit, and this is kind of your classic sort of semicircle hodograph for tornadic supercells here. Just take a look at the amount of streamwise vorticity here. We've talked about this before. Streamwise vorticity, going to draw your storm relative wind vector toward the level at which you're assessing, then draw your horizontal vorticity vector, which is always perpendicular to the hodograph. And that you see so much streamlines vorticity here in pretty much the entirety of the lowest few kilometers of this hodograph here. Just a pretty incredible amount of streamlines vorticity here. And again, with low-level instability so strong, you are going to have that streamlines vorticity ingested by the supercell, stretched into the vertical very, very efficiently. So this was getting to be a situation that was extremely favorable for tornadic supercells, right along that, with supercells along that boundary. This was a little bit to the south east of Dodge City at 0Z. The Dodge City sounding looked a little bit contaminated there. The temperature had dropped, very saturated profile there. So this was likely affected by precipitation or convection of some sort. But this was very much nearby, just to the southeast of Dodge City, basically near the Coldwater, Kansas area. You can see by 0Z still an extremely favorable environment. Wind shear had increased significantly by this point as well, as that low-level jet started to ramp up nocturnally, as it usually does here, up to about 40 knots or so. Still maintaining that just ridiculous amount of streamlines vorticity here in the low levels, all the way up through the lowest sort of couple kilometers of the hodograph. So any supercell that was going to track in this environment, highly unstable, highly sheared environment, was going to be a tornadic supercell for sure. So we go to let's take a look at our, we did not have a 0Z Dodge City sounding because the storm was ongoing so nearby. But so as we saw here, our storm just was looking pretty much incredible here just before 6 o'clock. First tornadoes occurred just before 6 p.m. Central Daylight Time here. That wall cloud continued to look beefy throughout the early portion of the life cycle. And then we had our first tornado of the day just before 6 p.m. Central Daylight Time there. It was a nice ropey tornado that turned into a pretty stout tornado as it moved off toward the north-northeast, tracking in the general direction of Dodge City. After this, this storm went through a number of cycles here. So we'll back up here. So this is going to be radar imagery from the Dodge City radar. So the Dodge City radar is right here. The town of Dodge City right in that vicinity as well. These are all going to be wind farms here. You'll notice that they will not change position here. These are all wind farms that are being picked up by the radar. So as we go through here, let's go ahead and go through our radar imagery here. So you can see the dry line here on the Dodge City radar right in here. First blips show up just before 5 p.m. right in here, right along that outflow boundary dry line intersection. Anytime you're chasing storms and you see an outflow boundary dry line intersection like that, you know that the convergence is going to be enhanced right at that point where they intersect, and that's going to be your favorite spot for supercell development there. So we go forward, we get blips to fire, and they quickly intensify as they move off toward the north. And you can see a couple of updrafts there. So there were a few different updrafts there that needed to consolidate themselves. A few different storms here. But you can see very quickly, given the high low-level shear, they were already taking on that supercell kind of kidney bean shape there. Small hook echo there developing there near Mineola. And you can see within pretty much 5 minutes or so, we go from 20 to 14, so 5:14 p.m., kind of just a few different updrafts here, kind of struggling. Within 5 minutes, they consolidate and become a very well-defined, pronounced supercell here, moving off toward the north near Mineola. Still had to compete with a couple updrafts. Then eventually that southern storm, that southern updraft took over and was able to quickly become tornadic here by about 5:30 p.m. or so, 5:30 to 5:45 p.m. You can see very classic supercell shape there. Precipitation, as we saw with the hodograph, vented out a little bit ahead of the mesocyclone, but again, the mesocyclone was kind of detached enough from that precipitation that it wasn't going to be an issue as far as storm visibility or tornado visibility goes. So quickly developing a very nice hook echo, and then we had our first tornado there right along that boundary, and you can see what happened here. Here's your precipitation. You can see this kind of fine line here really wrapping that outflow boundary up, and just the tornadogenesis processes went rampant from here on out. And as we loop through this, I'm going to loop through this at real time. This is about as classic as it gets. That vorticity from the dry line, from that outflow boundary, getting wrapped in really hard there at the tip of the hook. This is about as well defined of a supercell as you're ever going to see. Just take a look at that. That is just about as ridiculous as it gets. That outflow boundary getting wrapped in, that strong streamwise vorticity there, wrapping into the tip of that hook. That is a radar image to hang on the wall, to put in textbooks. And it continued to do so. You can see the first tornado there, and moving toward the Dodge City radar in the general direction of Dodge City. Tip of the hook there. So the first tornado, these tornadoes were occluding toward the north. So you could see there that we had tornadogenesis there occluding toward the north, wrapping kind of back into the western flank of the storm. New tornadoes developing toward the east or southeast of that, the initial tornado there. Just with that amount of streamwise vorticity, we're just going to get continued tornadogenesis here. I'll play the rest of that there. Continue to occlude to the north. And then eventually we got lots of storms to fire there near that boundary once that perturbation came through and the low-level jet ramped up. And it eventually merged into a clustered kind of mode there. But just some absolutely beautiful tornadoes from this storm. Continuous tornadogenesis with this storm. The tornadoes would occlude toward the north. And you would get tornadogenesis out here, as you saw in that initial photo. Let me go ahead and bring up some pictures here of the tornadoes themselves. So here was your first tornado. Nice, beautiful tornado there. So you can see there, here's our initial tornado, the ongoing initial tornado there. Very stout tornado. This was rated EF3. But then you had your secondary sort of circulation develop here just to the east or northeast of that initial tornado. So we went on here, and this shows it nicely. This was the initial tornado starting to occlude pretty nicely. You can see that kind of getting wrapped up, kind of occluding there nicely. Then your secondary circulation here, big fat wall cloud associated with the second circulation, producing several tornadoes as well. This one we had 3 tornadoes on the ground in progress at one time. Just an incredible scene to watch from a scientific perspective, as well as just a storm chaser perspective, which was just incredible to see. And of course, as we said, we ended up seeing approximately 13 tornadoes. According to research from Wienhoff et al., a couple of my former colleagues at the University of Oklahoma did some research looking over the mobile radar data from RAXPOL, and they found that there were 13 tornadoes from this one supercell in total. So pretty incredible stuff from this supercell. You can see it's just some absolutely beautiful scenes here with multiple tornadoes in progress at once. And then eventually we had a very strong tornado moving off in the general direction of Dodge City. Started off as a multi-vortex tornado that turned into almost a wedge-shaped tornado there as it went through the west side of Dodge City and produced a decent amount of damage. A couple more tornadoes occurred as it passed to the north of Dodge City, and then it eventually kind of became a more clustered mode and eventually dissipated. But it was just an absolutely incredible storm. So hopefully that enlightens some of the meteorological aspects of just one of the most impactful, one of the most notable meteorological storm chasing days in recent memory. Haven't seen a day like this since. For a lot of chasers, it's their career day. It was incredible to be there and to witness this storm produce tornado after tornado after tornado. And it was really cool to go back and look at the meteorology behind this event. So with that, thanks for watching. We'll have a lot more of these case studies coming up in the near future. Thanks for watching. We will see you in the next video.